Okay, this is for graphs and transformations. The first one we are doing is a cubic graph. So cubic graphs look like a roller coaster. So they kind of go up like this or they go down like this. Okay. So in this first example, they ask you to sketch a cubic graph where they are the whole equation is already factorized. That's why there are brackets. So when you factorize a cubic equation, and then you will get in this form. So you'll see like x is the first one. So x doesn't have a bracket because it's more like a x minus 0. And then let me see. We need to find where they cross the axis. So we find that using uh, the intercepts. So you can take the equation and equate to 0. That means when y is 0, then we can find where it touches the x-axis. So you will get x is 0, or x is 1, or x is minus 1. Basically, you just take each item like this one equals 0, this one equals 0, this one equals 0. You get these three answers. So then we will label, you must cut at 0, 1, and minus 1. Okay, so it's like, must cut here, here, here. So at least you know how to draw, but you need to decide is it a curve that's going up or going down. So how we determine that is that you just look at the x power 3 sign. You see when this x multiply to this x and this x, you're gonna get x times minus x times positive x. So that is gonna give you a negative x cubed. Means that it's a curve that is going downwards. So it's like that. Okay. So once you have determined that, we can draw. So let me try going down and up and down. Down and up and down. So like this, negative 1, 0, and 1. Okay. So to check whether it has a y-intercept is when you can sub your x to be 0. Yeah, but when you do that, then everything turns to 0 because the front one is already x. So 0 times everything else is 0. So y is also 0. That's why we cut at the origin 0, 0. Same as the x-intercept. Okay. Okay, next one. Next one is a reciprocal graph. So I listed out the main kinds that you should know. The 1 over x graph and the negative version, and then the 1 over x squared graph and the negative version. So you can, you have to memorize that 1 over x looks like this. Okay. Try not to let it touch the axis. So it should be like parallel, going nearer and nearer to the axis, but never touch. So then the negative of a 1 over x will be, it's like the one on top you flip down, then the one below you flip up. Then it will look like this and this. Okay, so you like flip those that were up, come down, down, go up. And then for 1 over x squared, it's like, it's x squared. So you just tell yourself they are positive. Positive. So they curve, both of them, but then they are above the x-axis. So the negative version, so those that were up will come down. So then you flip down this way, this way. So these are the general shapes that you should know. And if they give you any other thing like a 4 over x, 5 over x, it's gonna look the same. Just that if it's 1 over x is here, if it's 5 over x, maybe it's higher because you times 5. Okay, but the shape is the same. So example in here, they say sketch the graph. One is there's a 4 on top, one has a 12 on top. So, but they both have the same 1 over x, the main template, the same shape. So if you're gonna do 4 over x, you'll do, oh, cannot cut that part. Can do like that, like that. Then you can label this as the 4 over x. But then for the 12 over x, I need to make it higher. Because for the same values, basically it's like 4 over x you times 3, you get 12 over x. So it has to be like 3 times higher. So you can just draw something like that. It will still have to go towards near the axis. Yeah. Okay, basically it's higher, okay, but doesn't mean that it's floating above. It will still eventually have to go nearer and nearer to the x-axis, okay? Okay, moving on. Points of intersection. So if you have like cubic graphs intersect reciprocal, then how would it look like? So let's try here. So for the cubic, this one is the cubic, this one is the reciprocal. So cubic, we need to find where it touches the axis. Then I can draw the up, down, roller coaster looking curve. And then I have to check, is it a going up or going down kind of roller coaster. So for that, this one first, we equate to a 0. So we can find the intercept. So x squared equals 0 and the x minus 3 equals 0 and x is 0, x is 3. So I must cut at 0 and 3. Okay. Then where else? I need to find when x is 0, when x is 0, the y is also 0. Okay, so it cuts there. Go up. Okay, see, if I try to prepare how to look at it, if I draw like that, right, I cannot make it go down again because then it will cut here one more time. I only can cut at 0 and 3. So again, okay, let me check. Is it have going up or going down? So you look at the x squared times x, it's positive. Positive x cubed. So it's going up. So okay, if it's going up and it cannot go down and come up again because I cannot touch one more time, it's only 0 and 3. So then it probably has to be let me see. Maybe like this, then go up. Yeah, so okay. So it must have like that 2 humps. So you can turn here. And turn up like that. Okay, can. Then for the other one, so the y equals 2 over x. So that's the reciprocal graph. Let me change color. It will be like this and like this, right? Y equals to 2 over x, the basic shape of it. Y equals x squared. Okay. So they want you to explain how your sketch shows that there are only 2 real solutions. Okay, to this equation, but that equation doesn't look like the ones that we have. Let me show you why. So this thing does not look like these two put together because there is no 2 over x there, right? So what happened is when there's an intersection in two curves, no matter what, you have to just take the two equations and put them equals each other. But see why they only have a 2 here? The over x moved to the other side. So they just like shifted things around. So the x moved the other way, then you get x power 3. So it's basically the same thing as the equaling them together. So when they ask you to find the solution of this, you just look at the curve, the two curve you have, And they say two real solutions. So yes, you see the solution where they intersect 1 and 2. So yes, from the sketch, we can see the two circled points is the two real solutions because they intersect. Okay. Okay, now with the transformation, so I'm taking this example for x squared, the quadratic curve. And this one, the normal x squared will look like, it will turn at the origin 0, 0. Okay. Then for what you see here, the now they bracket, the square is still outside, but then now x have to minus 2. So this is like moving the curve left and right on the x-axis, right? But here they put minus 2. For x values, we will take it like the opposite way. So if they put minus 2, you do plus 2. That means you plus 2 on the x-axis, means you're moving it to the positive side, the right side. So instead of cutting at 0 now, you will have to cut at 2. Okay, so then it will like shift this way. It moves to the right. Okay, that translation. And the part C, the minus 2 is not with the square anymore. The minus 2 is outside. So it's like this thing, but minus 2, right? So this is affecting the y value because it's not in the x with the square anymore. So it's outside, so it's with the y value going down by 2, minus 2. So this one we take it directly. If they give you minus 2, you go down 2. So from the part A, that kind of x squared curve, you're gonna have to go down by 2. So you're gonna cut at minus 2, okay? So these are all going up, down, left, right. They are translations. Okay, so now for this 1 over x graph, we know that 1 over x graph looks like that lah. Okay, but then I want to do a translation for this x plus 2. That means the x value plus 2, meaning we do always do the opposite for x1, x value. So if it's a plus 2 there in the bracket, means I have to minus 2 in reality on the curve. That means normally it's like this. This is the 1 over x, right? But then I have to move to the left now, minus 2. I have to minus 2 because the bracket did a plus 2. That means it will shift. So if you notice, this is 1 over x. There is a asymptote. That means they cannot touch x equals 0 and y equals 0. These are the axes. So if you're moving to the left by 2, the asymptote follow along. That means now I cannot touch minus 2. And yeah, I cannot touch minus 2, but the y equals 0 stays. Okay. So now, wait, let me remove. So now I cannot touch that minus 2 because the asymptote is also x value, so that got affected. So it's like that and like that. Okay. So that was translated to the left side. Now for this one, you see the plus 2 is not in the bracket, it's outside, so it's affecting the y values. The y value, that means must go up. So at first, this is the curve. But then, so now it affects the y equals 0 asymptote. Asymptotes are the lines that the curve cannot touch. So if it goes up, that means now I cannot let the curve touch y equals to 2. So let me remove. So it goes this way and this way. Okay, so it's like the curve, this two curve thing got shifted up. Okay, how about the other kind? So when there's a times 2 in front of fx, times 2 is not in the bracket, it's outside bracket, so it affects y value. Y value doubles times 2. So imagine you were like this, but then now you will still have the same shape. Yeah, you still have the same shape of the 1 over x, but basically it's supposed to be higher. Where is the... Oh, okay. So basically it's a 1 over x, but then times 2. So it becomes like 2 over x. So if you have, let me do in black. The 1 over x maybe looks like that. Then I do in blue for the 2 over x will have to be higher. Then this one's lower lah. Or it's more negative. This one is the 2 fx. Then this one is the fx. Okay, so it went higher. And the bottom part, it went more negative. Because when you times 2 to a negative number, then become more negative also. Okay. So for the part D is a bit more tricky. Let me draw. Because the normal graph is like that. So if the times 2 now is inside the bracket. So it affects the x value, the y value stay the same. So maybe I put a number here. Maybe here like, because this is a y equals to, I put this, I put this 1 over x. So when x is, let's say, when x is 2, wait, I think I write outside. When x is 2, right, you sub into the equation, you get 1 over 2 for the y. Okay. But now, because this thing, we have to, they call this scaling by a factor. So this one we are scaled by a factor of 1 over 2. That means you take the x value, like number 2 here, we are going to half it. So this is scale by a factor of half. So for x, again, everything with x in the bracket kind of do the opposite. So like just now we said when it was plus, then we do minus. But then for this one, when it's times 2, we kind of divide 2 to the x value. So at the same point, this point, the x value have to half. That means you get a 1. But the y value stay the same. So there's like 1. It has to go 1, but the half is still y value. So it goes this way. Okay. And then where else? For the negative also, negative 2, negative 1. Yeah, it will go this way. So then your curve is the same shape, but they kind of become more compressed. Squished up like that. Okay, like they got squished, okay? Yeah, I'll explain more below. So the blue one, y equals to 2, no, sorry. The 2x there means you sub into x. So it was actually 1 over x, right? Now it's actually 1 over 2x. Yeah. 1 over x, yeah, okay. This one is, let me change the ones there also. For this, because it's for part C it was 2 times the 1 over x, so it's 2 over x. Then for original is 1 over x. Okay, now this one is easier. The negative version of 1 over x is just a reflection. You flip it up and down like what we said just now. So that will be here and here. This is basically negative 1 over x. Okay. So basically you can see this as it's a mirrored on the x-axis. You take x-axis as the mirror and then you flip it. So then the other one, again, this one is the negative is in the bracket with x. So we will think that it affects x, but then we are not taking x as the x-axis as the mirror. We take y. So mirror on the y-axis. So actually it was like this, but now I have to use the y-axis as the mirror. So instead of flipping up and down, it goes left and right. Then oh, it looks the same. Yeah. Yeah, it looks the same. But this one is yeah, because actually if you do a negative x, right, you sub it into the equation, it's like below, but it's the same thing because the negative can come up also, so it looks the same. Yeah, but not every time it looks the same, okay? So it depends, but this one for 1 over x, it will look the same. But yeah, you can see if you mirror on the x-axis and the y-axis, it gives you the same shape. Okay, but the steps are different. So there is this that you can take note. This is very straightforward for you to refer every time you need to do a transformation. And so you can see like here, I highlight the ones in yellow because that one is the more confusing one, especially because the factor affects in the bracket x. Those that are outside bracket, like in front of f, x, those are very easy because it just tells you to shift up, shift down, that kind of thing for the y values. But for example, this one, it affects, you have to reflect it. So like the mirror is the y-axis. And if you're looking at the coordinate, yeah, you can follow all these. It gets shifted. Only the x values get affected in this case. And for this one, the scaling, if they do ax, like 2x, f2x, like just now, when there's a 2x, we think that the graph will get stretched by double, but actually no, okay? So because the factor, instead of times the factor 2, like here, they do like 1 over 2 just now, right? So that's why I write here 1 over a, and the x values will get divided by that factor. Okay, so when you think of it as a f2x, it is actually compressing the graph. And then when you do like x over, it's like a half x here in the bracket, is actually you're stretching out the graph, stretching this way. Compress is this way. Okay. Yeah, all is like horizontally. I'm talking about not vertically compression, all that. Okay, we're done for this chapter.